Welcome to the kickoff of What's New in Autodesk Fusion for 2024. Communicate feedback directly with us by signing up for the Insider program linked in the description. This release is a comprehensive upgrade across various workspaces. From introducing advanced swarf strategies in the manufacturing workspace, to the implementation of automated drawings, plus the introduction of new simulation constraints. There's a lot to explore. We've made significant strides in refining Fusion, ensuring that each feature increases the overall efficiency of your workflows. Let's begin our journey by delving into the improvements made in the general Fusion interface. The Fusion homepage now boasts improved navigation, filtering, and search capabilities. These enhancements allow you to effortlessly filter files by both date and type, and utilize the newly integrated search function to swiftly locate specific designs. We're always improving performance in every single update, and this time is no different, but the list is simply long. I'll speed through a couple major improvements that I'm sure you'll notice in your day-to-day workflows. The measure command is 64 times faster than before, especially noticeable on models with a large number of faces or edges. Parametric timeline recompute saw a boost, as did insert into current design, open, save, edit in place, break links, and every joint editing or manipulating command that you can think of received significant speed improvements. Check out the blog post for specific figures, but try some of these commands and let us know what we should improve next. We have some exciting updates regarding the Fusion electronic workspace. We've rolled out a new selection behavior that will improve your workflows. The challenge of selecting a component from its part origin is now a thing of the past. As you navigate through the electronic workspace, the assets beneath your cursor will be automatically highlighted, making interaction significantly more intuitive. This enhanced highlighting supports the selection filter, press and hold to move components, or right-click for more options. The marquee selection style from the design workspace has been adopted. Dragging from left to right encapsulates only the assets fully enclosed within the selection box, whereas dragging from right to left includes any asset the selection box touches. This will undoubtedly expedite and enhance your design experience. Additionally, the SPICE simulation capabilities within the Fusion schematic workspace have expanded. SPICE simulation allows you to verify that the performance of your design aligns precisely with your anticipated parameters. Integrating version 41 of the NG SPICE engine will enable you to use PSPICE models. Therefore, you can now use models from manufacturers such as TI, Analog Devices, Microchip, and even compatible models from LT SPICE, and much more without conversion. Easily map your component directly on the schematic or within the library editor. Learn more about SPICE simulation in the Fusion help files. Try it out, that way you can verify and optimize circuit performance before committing to physical prototypes, saving you time and resources. In the design space, we have an update to the configuration interface, introducing some fantastic usability and quality of life improvements. Users can now enjoy parameter autocomplete for efficient setup, the ability to duplicate configuration rows for better data management, and the flexibility to move columns between theme tables for efficient organization. Additionally, the configuration insert UI has been refined with the Select Configuration dialog, displaying the different version numbers, milestone icons, and informative labels for preview images, whether they're unavailable or from a previous version. An improvement to sheet metal DXF export focuses on improving the precision of splines and curves. When exporting a DXF file of a flange sheet metal component, users will notice an enhanced stability in both the position and orientation of these elements. Previously, there were instances where circle segments and splines would become shortened or have their orientation inverted upon export. An improved insert command now permits the insertion of components directly into an unsaved design. This update enhances users' ability to incorporate external components into an unsaved assembly, and create in-context external components without the need to save the design first. The tree has been enhanced with a visual out-of-date indicator for components. This feature makes it immediately apparent when a nested component is out of date through the use of a colored triangle indicator on the top level inserted component. The indicators are color-coded for quick reference. Red signifies a missing reference, yellow points to an out-of-date reference, and blue indicates an assembly context that is out of sync, particularly when editing in place. The visual cue system aids users in maintaining an up-to-date and accurate assembly design. This release will bring Sync All Context capability into the Get All Latest command, creating a single location to update both assembly context and references in a single action. This simplifies the user workflow by consolidating multiple update actions into one, ensuring that all components and assembly contexts are current with minimal effort. Your competitive edge is often defined by how quickly and efficiently you can bring a product to market. As part of Autodesk AI, we've added drawing automation to Fusion, revolutionizing the creation of technical drawings. It's especially impactful with sheet metal, turned, and prismatic components for 2.5 to 3-axis machines, enhancing efficiency and eliminating any redundant steps. The new system automatically scales and lays out drawings, places parts lists and balloons, rotates components for optimal orientation, and breaks down longer components, and finally applies center lines and marks. It handles sheet metal specifics like flat patterns and bend tables, or adding hole and thread notes. Using generative dimensioning strategies, it reduces your overall drawing time by understanding the dimensions that your manufacturing requires. Although it's designed to function effectively right out of the box, it offers customization options for templates and settings, providing a flexible and comprehensive drawing creation tool that responds dynamically to user feedback. Breakout section views enable the creation of partial section views of components, focusing on a particular region to reveal internal details that are otherwise hidden. This feature is particularly useful for highlighting critical features, simplifying complex views, or emphasizing important elements of a design. By default, breakout section views are configured to cut to half the depth of a model. The introduction of custom sheet sizes significantly enhances your user control and flexibility in the drawing creation. This feature allows users to specify their desired sheet size during the creation of a new drawing, or when editing existing ones under sheet settings. A useful note for users is the new ability to mix and match standards. This cross-standard compatibility expands the range of design possibilities and allows for more tailored drawing layouts. Responding to numerous customer requests, the latest update introduces solid fill hatches, along with a revamped look and feel for the hatch command. This enhancement is visually represented through new preview icons, making the selection process more intuitive and user-friendly. Additionally, users now have the option to further customize their section views with 15 new hatch patterns, expanding the range of visual detailing available. Dropping into the simulation environment, we have a few updates here as well. The Cloud Previewer improves your ability to check generative designs before execution, now running the previews on the cloud. It quickly validates preserve and obstacle geometries by running the initial iterations of a study, offering early insights into the impact of loading setups on geometry. Moreover, this advanced tool supports all manufacturing methods, eliminating rigid body modes and accommodating for advanced constraints like buckling and modal frequency, making it a more robust and efficient solution for design iterations. Next up is manufacturing, and we are yet again adding additional new toolpath strategies and features to increase your machining, additive, and nesting productivity. Swarf machining utilizes the side of the tool instead of the tip, reducing cycle time and in many cases can increase the surface finish quality. A new advanced swarf toolpath is now available, which gives you more control and additional advantages. This new toolpath provides greater flexibility for inputting contour or surface geometry and can degouge the machining surface. Greater tool access control is gained with the flexibility of auto-synchronizing between the top and bottom rails. The advanced swarf toolpath is not only restricted to 5-axis machining, allowing for toolpaths that are 3-axis, which is very useful for vertical walls, 4-axis for wrapped cylindrical features, and 5-axis for complex geometries like undercuts. Blend is a versatile finishing strategy for machining the shallower regions of a part between selected contours with a constant cutting direction, and supports 3-axis undercut machining with applicable tools. A new way to define blend toolpaths is now available, producing toolpaths that avoid fragmentation on complex geometries, enabling them to be machined to a higher surface finish more easily. To select the new method, choose the From Tip of Tool option for step-over calculation on the Passes page. The pre-existing method can now be selected by choosing On Surface. Deburr and geodesic toolpaths can now be optimized using the Trim, Delete Passes, and Move Entry Position functions, bringing them in line with modification capabilities offered in other strategies like Steep and Shallow. These two toolpaths will now support the Replace tool functionality, allowing tools with identical cutting geometry but different configurations to be quickly replaced. A new standalone groove roughing strategy for external, internal, and face grooving operations has been added. It incorporates all the elements that users loved in the old grooving toolpath, but with superior results by giving the user more toolpath control through a simplified UI, improved boundary handling, and an improved set of tangential extensions. This gives you a safer and more efficient lead-in and lead-out, allowing for a better and more consistent toolpath. The option to define the entry point of the groove in relation to the center or the side of the groove minimizes tool deflection and controls swarf. Machine simulation has been greatly enhanced with the addition of collision detection. The model, stock, tool assembly, machine tool, and fixturing are all checked against each other for collisions, and if found, are then highlighted on the screen and in the toolpath bar. This enhancement gives you greater confidence and increases the safety of your equipment during the machining process. When simulating your toolpath, a new Rotate Stock view gives you a new way of viewing, which rotates the stock instead of rotating the tool. This type of view can be beneficial to users programming parts to be machined on turn mill machines, as it more accurately represents the movement of the machine tool. Some 3D printers have areas that are reserved for purposes such as storing thermal monitoring equipment or bolting down the platform to the printer. These regions are commonly referred to as no-build zones. Users can now edit machines in their local or cloud libraries and designate a no-build zone using a 3MF file. No-build zones are visualized in additive setups as red volumes and are listed in the browser so that their visibility can be controlled. These no-build zones are also considered during part arrangements to avoid positioning components within that area. When trying to 3D print large components, it's important to find an orientations for parts that will fit the build volume of the printer. The Automatic Orientation tool now has the option to calculate and display part orientations that will fit your printer's available build volume. An important step when creating an additive setup is the arrangement of the components in the available build volume. The Monte Carlo Packer creates arrangements which are beneficial for self-supporting additive processes by moving parts as low as possible to minimize the build height. Part orientation can be selected and maintained throughout the packing process. Additionally, a Select All command has been added to the Additive Arrange dialog, simplifying the selection process. After automatically arranging parts within the build area, we may end up with excess parts that cannot be printed. It is good practice to remove these parts from the setup. A new Remove Excess Components feature has been located on the right-click menu, allowing for these components to be easily eliminated from the active setup. Setter support structures, which are typically used in metal binder jet printing, can now be separated from their source body. With one click, you can now create a new mesh manufacturing model, enabling you to streamline your build preparation process. A new preference selection has been added in manufacturing preferences, giving users the ability to view additive arrangement statistic results by the build volume or build height. The 2D rectangular arrange is a new solver that creates arrangements which are best suited when using straight cut machines like saws or shears. And that's the last of the updates for Fusion in January 2024. We look forward to seeing how you leverage these new features, and make sure that you review the blog post for additional details on all the latest enhancements. Until next time, thank you for watching from the Fusion team, and let's keep on pushing the limits to make anything.